Give me a second now. It is working. Okay. So I also say hi to those who are going to watch this video eventually. And today we are going to talk about some of the concepts from, I'm just going to talk about 3 things, maybe a 4th one, because you might be asking about the construction part of it, because this section contains an example where you have to construct using a compass. So I'm going to talk about that first. We are not going to do that yet. That's all I have to say about it. So anything related to construction part of it is a little bit harder if you are doing this online. I have a way to do it, but I prefer to put it off until last minute. It means until I make sure that we are going to go back to school and everything after May 1st. So it means I'm going to make some adjustments to the curriculum. But for now, I'm going to keep it that way so you don't have to worry about anything related to construction, okay? Now, with that said, now let's begin with 3 things we're going to discuss today. The first one is more about some definitions, understanding some concepts, and the next 2 are going to be dealt with the main part of today's lesson, which is doing some geometry on the coordinate plane, talking about perimeters and areas of triangles and quadrilaterals, okay? But before we get to that part, we're just going to talk a little bit about figure that is formed by 3 or more line segments. So I'm going to show you 2 example line segments. I'm going to give you another example, 1, 2, 3, 4, and 5. You can have as many as you want as long as it is 3 or more, okay? And they have some names. You can check that on page 4. One is called a triangle, a 4-segment or side polygon is a quadrilateral. You're not going to say rectangle or square or anything else, because we are just saying it's a 4-side polygon. That is the only information you have. It means that you can only say it's a quadrilateral. As we provide more details of that polygon, then you could be able to say rectangle or square or something like that. This is not going to be part of our discussion yet, but just so you know, okay? And you have those names on the book, so I don't want to go over those. Just to clarify, and that is why I wrote these 2 different polygons, because the way that it's being constructed, we have 2 other classifications, okay? So we're going to say that this is a concave polygon and this one is a convex one. And why? Can you see what happens in here? The polygon that is kind of entering in the polygon. It's like a cave. So probably it's school. That is the convex one, because all these connections, vertices of each of the segments is kind of going outside, outside the polygon, and that's the difference between convex and concave. But in this case, if I want to measure these interior angles, look at this one. This interior angle right here, this angle B, C, D, and E. Angle B measures more than 180 degrees. That is a characteristic of a concave polygon. Okay, just to clarify. And one more thing, depending 1, 2, 3, 4, 5, that's another pentagon. That's all. Okay, now let's move on to the main section of today's lesson. We're going to talk about areas and perimeters in the coordinate plane. 2 exercises. If you have the electronic version of the book, I'm going to go to page 408. And after examples 2 and 3, you might see some other, extra examples. I'm going to do 2 of these. Doing exercise number 5. Let's do exercise number 5. Okay. So, in this case, I'm going to modify the instruction and I'm going to add something else. Okay. So in this case, we are going to find the perimeter and the area of the polygon. Okay. And that's what I'm going to do in number 6 as well. I'm going to modify it. Okay. So let's begin with number 5. We are given 3 points with their corresponding coordinates, and these ones are G, it's located at 2, 2. H, it's located at 3, -1. And J is located at -2 plane, or if you have any copy available of a coordinate plane, go ahead and do it. I have to construct it here. So this is the first thing I'm going to do. All right. So here we go. We have the y-axis and x-axis. So here we are, right? So let me label them. And now let's start locating each of these points, okay? Let's use orange. So we have G is 2, 2, so 2 to the right and 2 up, okay? So this is where G is, all right? So G is 2, 2. Then we have H, which is located at 3, -1, so it's 3 and -1, somewhere over here. Can you see it? You can see it. Wait a minute. Yeah, I think you can now see it. So this is H, located at 3, -1. And now J, -2, -1. Hopefully this is something really easy for you to do. And now let's draw the figure. So let's use a blue. Okay, here we are. You have the easier ones in the quiz and in your homework assignments, I think. Yeah, so, yep, let's go for it. Let's begin with the perimeter, okay? So the perimeter of this triangle is just adding the lanes of each of the segments, okay? And I hope that you can see what I see, that the easier one, or the easiest of these 3 is JH, okay? So if you want to find the perimeter, let's find it here. So the perimeter will actually be doing this, JH, yeah, the length of that segment, plus HG, right, of the segments, and then we add them together, we're going to find the perimeter, okay? So let's begin. As I told you, JH. JH, if you go from -2 to 3, you just have to count 1, 2, 3, 4, and 5. So it is 5 units, okay? And we do that because it's a horizontal length, all right? Or distance. We use the distance formula, remember? Okay, so let's go for it. HG, let's do HG, which is, GH is the same thing, but I'm just being consistent here, okay? So HG, in order to find this distance, be careful, it's a length segment, so we just don't count things, no. To break it down in its horizontal and vertical distance, so I do this, right? It's something like this and then this, all right? So it's like I have to go 1, 2, and 3 units up, right? From this point to this point, but then from here to here is just one unit to the left, okay? So if I have to go from this point to this point by doing 3 units up and then 1 to the left, I'm going to write them here. 3 units up, and then I square it, plus 1 unit to the left, I square that, and then I have to take the square root of this. And this is going to be square root of 10, Gj. So Gj, I need to know how much or how many steps you have to go to the left, and then you go 1, 2, and 3 units down, all right? So this is going to be easier because you do 4 units, you square that, and then 3 units, and you square that, and then you take square root 5, which is 5, and I'm good with that. So I'm good with this. So this is a 5. This is also a 5. So the perimeter of this triangle is just adding this segment, and this segment. So perimeter will, so you can do this. It's 10 plus square root of 10. But if you are asked to give approximate answer, what we would do is, well, you use your calculator. I'm going to use Google Calculator, and the square root of 10 is it has 3.16. So the perimeter of this triangle would be 10 plus 3.16. Hence, the perimeter is 13.16. That you could say 13.16 units. If at the beginning they told you, all right, you are measuring these units in meters, inches, feet, then you would say it's 13.16 units, or sorry, meters, feet, inches. It depends on the model, the setup of the problem, right? But for now, that's how you calculate a perimeter in the coordinate plane. Okay. Remember, this is going to be uploaded on YouTube, so you can rewind it and this. Okay. And remember that we need to take into account the formula for the area of a triangle, which is base multiplied by the height, and then you divide by 2. The base is easy here. This can be the base. Base is can be any of the segments of the triangle, and then measuring the height is where you need to choose the one that is more convenient for you. At this point, it's easier to use this segment JH as the base, so that the height or altitude of this triangle is going to be a segment that is perpendicular to the base, and also that comes from the vertex that is opposite to this segment. What is the opposite segment to this vertex? The opposite vertex to this segment is this point G right here. So if I drew a line or a segment that goes, like this, can you see that they are perpendicular? That's the height of this triangle. So I need to take that into account. Distance from G to the base, which in this case, it's 1, 2, and 3. Okay, so in order to calculate the area of this triangle, I'm going to do it here, and I have enough space here. So the area of this triangle is, remember, base is 5. Wait a minute. Okay. It is 5 multiplied by the height, which is 7.5, and then you're good. Okay. And honestly, I think it's harder doing this with triangles than doing this with rectangles. Okay. Because the next exercise is we have to do it using a rectangle because we are given 4 points. Okay. It's very simple. So I'm going to erase this. Now, you will have this on your YouTube video. I should have left the instruction because it's the same thing. Find the perimeter and the area of the polygon. But anyway, okay. So now I'm going to do exercise number 6 from that same page. 408. Remember that I am modifying a little bit the instructions because I am adding one more. So we have to find perimeter and area, okay, of the polygon. Whose vertices are. So the vertices are n, which is -1, 1. Now we have p located at 2, 1. We have q located at 2, -2. And finally, we've got r, which is at -1, -2. All right. Okay. So again, we're going to draw the coordinate plane. Here we are. Okay. And then the intervals. This is where n is. Then 2, 1. Right here. Oh, by the way, new way of giving extra points for participation. Yeah, because I don't have a way to find it out yet. Well, I actually did something on the announcements. You can see that there is a forum, discussion forum, but seems like there is no activity on it. So, well, yeah, just keep that in mind. Well, so let's continue. And we now locate Q, which is 2, -2. Looks like it's a quadrilateral, right? And then we just have to, because we have 3, 3, 3, yeah. And this one is actually really easy because look at this. We just have to think for this 3 and 3. So perimeter, you just have to add them all. So it's 3 plus 3 plus 3 plus 3, which is 12, 12 units, which in this case the base is 3 and the height is 3. That means it's a 9 squared units. Okay, not 9 square. Be careful because we already did this square thing with the numbers. It's 3 square, which means that it's 9 square meters, square inches, square whatever. Okay, well, and yeah, do you see that it's easier to deal with the quadrilateral? In this case, it was a square, so simple. Okay, so guys, I'm going to stay here for 1 or 2 more minutes. If you have questions, just let me know. You know, like quizzes and even test review and even test, because this section 8 was short if we didn't have the construction. We'll schedule the test for chapter 8. Okay, so as I tell you, I'm gonna stay here for 1 or 2 more minutes for what you wanted to see for today. But